never said that more is better, didn't have to deal with wrangling data in the age of big data. The explosion of data from everything we do has become a monster that grows in complexity the more it consumes. It gets bigger, slower, and wilder with every bite. Taming this beast hinges on turning the tangled mess of data that created it into something that flows. Something elegant, agile, and easy to use. It means crafting solutions that bridge the operational and analytical divide. This is where you shine, filtering and corralling the unruly. You transform and reshape data so it calms down, plays nice, has high value downstream. In your hands, data overload becomes a strategic advantage, and data chaos gives way to clarity. Behind the curtains, it's your designs and code, your ability to collect, process, and restructure data into meaningful new forms that reveals the beauty in the beast and the best in what software can do.
Please welcome Confluent's Chief Product Officer, Sean Klaus.
Hi, everyone. I'd like to extend a big warm welcome to everybody joining us here live in person and everybody joining us live online. Kafka Summit London 2024 is officially open, and we have a tremendous lineup of presentations, announcements, and breakouts for you around everything to do with data streaming. Now, this is my second Kafka Summit London, and I have to say how amazing it has been, how warm and open this entire community has been with me. You've been so generous in sharing your time, your thoughts, and your ideas with me. And it's let me kind of become an insider at rapid speed. And as Chief Product Officer at Confluent, that's very handy because it helps me guide our teams in ways that we can help you achieve more from your data. We want to be able to help you drive forward your projects, your careers, and be able to help you through the Confluent products and through the open source projects. Now, I'd like to start out by thanking a few very important members of our community, the Kafka PMC and the Kafka committers, without which neither this conference nor the open source projects would be possible. Would you please join me in giving them a warm round of applause? Now, while it's fun to celebrate the individuals, it's also fun to step back and celebrate everything that this community has achieved together. We had a fun milestone just recently, which was the 1,000th Kafka improvement proposal was submitted for the project. Now, I'm not going to dive into the details of the actual kit, but it is incredible to think that we've now come together over 1,000 different times to propose new ways to make Kafka an even stronger foundation for all your data infrastructure. Now, it's that idea of building a strong foundation for your systems, for your data, and ultimately for your businesses, which is at the heart of everything we are doing at Confluent. We want to make it easier for you to do more, faster than you ever have before. And to us, that means going beyond just helping you move streams of data, although we know that that is incredibly important. We have to move beyond the niche of speed and real time. To have truly transformative business impact, something more than just a handful of business-critical use cases, we have to address the way businesses approach their data and their data infrastructure. And for that, we need to acknowledge what data and data infrastructure usually looks like. Honestly, it's pretty chaotic. You might even call it messy. Why is that? Well, it's because the story of your data and your systems and your infrastructure, the story of your business needs, come together one at a time. Every time you have some new business requirement, you wire up the destination system to each of the pieces of infrastructure or data it needs to touch, one by one. You need to have a new mobile app, add in some wires. You need some new features in your web app, yet more wires. Every new need, more wires. And over time, your data infrastructure starts to look like a giant mess of data interconnections. And beyond complexity, all of these connections are actually surprisingly brittle. What happens when an upstream system change, A schema evolves in an inconsistent way. Data deviates from expectations. Well, all of those connections break, and all of the connections downstream from those connections break as well. You're constantly wrestling with data infrastructure. And yet, one by one, those projects keep coming, faster and faster. One day you need a new mobile app, the next day you need some analytical reports, the next day you need some new AI inference or classification. And so you keep adding all of those different brittle connections. We have to keep up not just with the rate of change, but with the rate of change of change. Now, for all you developers in the audience, you'll recognize that what I'm talking about here isn't just a set of architectural concepts. This is actually real-world developer pain. Have you ever had a pipeline that had been working fine suddenly start failing because a team 2 cubicles over has changed their system, mutated the way they present data, and they didn't even think about the downstream consequences of those changes? Or have you found yourself discussing your data structure with the developer 2 seats over who's hassling you about exactly what all the fields mean and how they can successfully use that data? As complex and as difficult and as intractable as this situation seems, this is actually as easy as it's ever going to get. It only gets more difficult from here. Imagine all of these problems when we have 10 times as much data, all feeding different AI systems. So doing more of what got us here won't get us there. Is there some way we can address all of these point-to-point connections and make all of this data less brittle? Well, there is, but we're going to have to change the way we approach things. We're going to have to move from a world where we connect every source to every relevant destination one by one. And we're going to have to move to a world where we do not have the data consumers reaching in and extracting data from the systems that they're sourcing it from, to a world where producers present well-formed data that can then be consumed by multiple subscribers downstream. Now, if you've heard these ideas before or you've worked with these concepts, you may recognize that I'm kind of describing data products. Data products have been around for a long time, and they're actually pretty simple. It's basically a well-curated, meaningful data set available in some shared place to be found by others with a well-understood schema and a set of owners that are responsible for creating and evolving that data set. Now, data products are meant to resolve this mess by reducing all of these underlying problems that we see. But you may be wondering, okay, well, Sean, you've just described that there exists a solution, and apparently it's well known in the industry. Are we solving the problem? Is this just a matter of implementation lag? Well, sadly, not quite. In fact, the general approach we've been using to data products in the industry has suffered from what is actually a fatal flaw. What's the flaw, and how can we address it? Well, for that, we have to dive back into the data mess. And if you look closely, you'll see that the data mess is actually divided into 2 separate but highly interconnected estates: the operational estate and the analytical estate. The operational estate is where all of your apps and microservices work together to deliver your business processes or to power your customer experiences or your employee experiences. And then we suck all of the data from the operational estate over into the analytical estate, where we try and piece it back together into a view of what has happened in the business, and then we want to be able to use it to make business decisions. Now, the thing about data products, or the way we've been talking about them, is that they've actually existed almost entirely in the analytical estate. And that kind of makes sense because they were originally conceived as a way to try and make sense of all of that complexity going on in the operational estate and try and reconstruct a 10,000-foot view across all of those different applications. But it also is where the flaw is. Because all of these data products, as well-formed as they are still being created from data that's ultimately coming from the operational estate that does not even know they exist. And so small changes in the operational estate can blow up one data product and all of the dependent data products. And you already put a ton of work into trying to reestablish what it all means in the analytical estate anyway. And all of that work is kind of futile anyway, because you've created these apparently really valuable data products, but it's almost impossible to bring those data products back into the online world if you need them, and do so safely. And so that turns out to be a big problem when you're building new use cases, and it's especially a problem now when we're all being asked to bring all of our data to bear in online AI use cases. So really, when we've been talking about data products, we actually haven't been talking about data products. We've been talking about analytical data products. And what we really need is a different type of data product. We need a data product that can exist not just in the analytical estate, but in the operational estate and between the two. We need a universal data product. Now, when I talk about a universal data product, I'm actually not talking about a high-minded concept. I'm not talking about some architectural thing that we're going to write a book about. I'm actually talking about technology well used and technology that you're already using today. A data product can literally be as simple as a Kafka topic with a well-defined and understood schema and an owner who's responsible for creating and evolving that data product. Those data products created using those components are just as reusable, discoverable, and reliable as the analytical data products we set out to create, but they can be used anywhere, in the operational domain and in the analytical domain. And we can scale up this simple process to achieve a whole portfolio of data products that power all of our use cases. And to do that, we use a data streaming platform. And a data streaming platform comes with 4 key capabilities that make universal data products easy at scale. Let me walk you through them very quickly. The first capability is streaming. Now, obviously, I'm not going to be telling the audience here at Kafka Summit London about streaming. You all know everything about streaming. But what's important to talk about in this context is that streams are the perfect substrate for universal data products because they can easily federate data both in the application estate and in analytics. And that's for 2 reasons. First, streams can be real-time. Now, it's often OK for some sort of analytical use case to be a little bit out of date. A few hours usually doesn't matter for a report or some sort of strategic analysis. But customers expect the operational domain to work in real time. They expect their experiences to be consistent and for things to react to what they are doing and to present back to them accurate information. And so really, low latency has to be the standard upon which you build all of these data products on top. Secondarily, streams are also inherently reusable. They naturally support this multi-subscriber model that I've been talking about. And that means that many people can consume the same data, and they can consume it in real time if they need it that way, or they can actually just consume that stream in batch as well. And that means that you can eliminate a whole bunch of these point-to-point links that cause the data mess, and you can enable an unlimited number of systems or users to connect and take advantage of these data products. Second, the data streaming platform comes with the capability to connect. You know, for data products to be truly universal, they have to be universally compatible with all of your systems across your estate, operational and analytical. You want any source system or any sync system to be able to be part of the streaming ecosystem and to do so really easily. So it comes with connectivity out of the box. Third, the data streaming platform makes it easy for you to govern. Now, it's funny, when people talk about governance, they often think that we are talking about security and reliability. And that is absolutely true. To have governance, you need to be able to apply schemas so that you have well-structured, well-formed data. You need to be able to apply data quality rules so you can be sure that data remains consistent and remains semantically valid. You need to have lineage so that you can see where the data came from and where it is going. So you do need to have reliable, secure data. But honestly, governance is as much about opening things up as it is about shutting things down or locking things down. Reliable, reusable data products can then be discoverable and understandable across your organization to keep driving value for every use case downstream, enabling data to reach its true potential. And finally, you need to be able to process the data to give it all of the rich domain context that it needs to be powerful for all types of use cases to be put to work by other people inside your organization. Now, it's obviously true that raw, full-fidelity data is useful, but if we shift the processing and contextualization of data to the left, so that teams can curate well-formed data sets with only with the domain understanding that they are really set to have. That means that more teams downstream can take advantage without needing to understand all of the nuances, and they can take advantage of prepackaged data, which is highly valuable. So if we apply all of those capabilities, how is the data mess looking? Well, it's looking a lot cleaner. You can still recognize the Kafka topics that you know and love, but now they've been joined and contextualized and connected to create higher order data products. And those Kafka topics, when they are made reliable and then made discoverable, become the universal data products that we have been talking about through this whole talk. And you can then use those data products to power all of your use cases, whether it's a new app, it's a new analytical report, it's a new AI feature, all of it from the one single source of truth. And the best part, more data products will naturally emerge. As your teams take advantage of the data products to power their use cases, they will produce their own data products that then become part of a whole portfolio of data value that you can apply all through your estate. We're breaking this vicious cycle where we're constantly wrestling with point-to-point connections and brittle data, and we're moving to a virtuous cycle where data keeps giving back to the whole. So let me briefly recap how a DSP makes universal data products easy. Firstly, we connect to everything, any source, any sink, whether analytical or operational, and bring it all into a broader streaming ecosystem. We govern the streams. We make them reliable through schema and data quality rules. We make them understandable through lineage and make them discoverable through data portal. And then we process them to make them rich, highly domain contextualized, so that more people can get more value from them easily. And that is literally it. You have those universal data products that anybody, anywhere, any team can take advantage of throughout your business. And they're available the moment the data is first created, in real time or in batch. So, have we solved those developer pains I talked about earlier? Well, we have. That pipeline breaking in the middle of the night doesn't happen anymore because you can rely on the data remaining semantically meaningful and keeping the shape that you expect it to be. And with data products, that conversation with other developers about what your data means and how it can be used, you can skip all of that, and instead you can just talk about what you're having for lunch. But enough about lunch, because it's going to make me hungry. Let's talk instead about how we do this in a little bit more of a granular way. And for that, please welcome my colleague, Rachel Groberman, who's been hard at work on the streaming portion of the data streaming platform, which we also call Kora. Please welcome Rachel.
Thanks, Sean. We can't talk about streaming without talking about Apache Kafka. As we all know, it plays a critical role in how we enable the delivery of data products. The Kafka community is stronger than ever. There are over 150,000 organizations running Kafka in production, over 27,000 GitHub stars on the Kafka project, and over 1,500 Kafka meetups happening around the world. Since Current, at the end of last year, we've had many exciting updates in the Kafka community. Apache Kafka has released 2 new versions, 3.6 and 3.7, which includes KIP 714 client-side monitoring and early access to the new consumer group protocol. I'm just in awe of the Kafka community. Not only is Kafka 4.0 right around the corner, where Craft is default and Zookeeper is totally gone, but there is also a new community Node.js client. What an incredible example of developers coming together to accelerate the streaming movement. Some other cool things my colleagues are working on are topic directories, two-phase commit, and last, but certainly not least, queues for Kafka. Shout out to Andrew Schofield on our team who wrote a 60-page KIP on it. I genuinely encourage you all to give it a read, but I'll give you the highlight right here, right now. Kafka 4.0 is targeting queues as well as topics. Unfortunately, I don't have time to get into everything the community is working on, but if you're interested in learning more, Kafka committers will be hosting AMAs throughout the conference. Now, when it comes to Kafka, or any other technology for that matter, you can't just take what you do on-prem, transport it to the cloud, and expect optimal performance. Here at Confluent, we've taken what the cloud does best and reimagined what Kafka could be. As a business evolves, so do its wants and needs for running Kafka. In the early days, you had no choice but to maintain full ownership of on-premise self-hosted Kafka. Huge respect to those of you who, out of regulatory needs or just personal preference, still roll your own Linux kernels. However, the natural evolution of running Kafka in the cloud involves a handoff from you to managed services that take over operational responsibilities for you, freeing you to bring your applications to market as fast as possible. That's where Confluent's fully serverless offering comes in. Customers that choose serverless expect it to just work while still being affordable with a lower cost of ownership than alternatives. Building cloud-native serverless offerings that just work and are also the most cost-effective way to deliver Kafka isn't easy. But that is the journey we are on with Confluent Cloud. So far, we've invested years of work. Roughly 5 million people hours over the course of the last 5 years have gone into developing Confluent Cloud. And at the heart of Confluent Cloud is the engine we call Kora. Kora solves a unique set of challenges that emerges with creating a true cloud-native service, such as how to offer a managed service to thousands of customers across tens of thousands of clusters, how to make it work across cloud networking, storage, and compute technologies, and how to automate operations so problems are solved at machine scale, not just human scale. And even though it's still delivering Kafka, Kora does so in a unique way. Kora delivers an experience that's fast. Less than a year ago, we announced Kora was up to 4 times faster than Apache Kafka. Now, here we are less than 10 months from that announcement, and Kora is up to 16 times faster. Let me show you. As you can see on this graph, for this workload that's running the open messaging benchmark, we measured a 16x improvement in P999 end-to-end latency. Kora is also elastic. You can scale up and down 30 times faster with Kora. But it's not just about speed here. It's about volume, too. Kora can quickly scale to up to 30 gigabytes per second of throughput. So, whether you're dealing with the demand of a major cricket match, the stock market opening, or one of the biggest shopping days of the year, Kora can scale to match any demand. Kora also offers better resilience. Our 4.9's SLA is 10 times better than other Kafka services that don't share our same cloud-native approach. That's why Sainsbury's, Bosch, and Goldman Sachs all trust Confluent Cloud, because it just works for their most critical and performance-sensitive use cases. And finally, Kora is more cost-effective. We've helped nearly 5,000 customers save on their Kafka costs. That's the beauty of a cloud-native service. As we continue to get more efficient, we will continue to pass those savings along to you. Best of all, you don't have to do anything to reap the benefits. They just roll out to you. Here's a great example. At Current, we announced a new way to experience Confluent Cloud, our enterprise clusters. With Enterprise, you get true elastic scaling clusters with enhanced security that includes private networking. But today, we are announcing a further price reduction coming to throughput for Enterprise. We're slashing throughput costs in half and also announcing a new entry point for Enterprise as it now scales down to a single elastic CKU. Altogether, this means Enterprise will deliver 1 gigabyte per second of throughput for up to 50% less. So, getting started with an elastic scaling streaming service with all of our enhanced security features and our industry-leading SLA has never been more affordable. Enterprise is already out on Azure, and Enterprise is coming soon for AWS. Let's get into what makes Enterprise so special. Streaming data is naturally variable and often unpredictable. When self-managing Kafka, operationally, you are always capacity planning, which is very difficult and almost ultimately leads to over-provisioning, which is painful for your bottom line. While all Confluent offerings scale elastically, the new Enterprise tier takes this one step further and doesn't require reserving capacity. Enterprise instantly scales from 0 to 1 gigabytes per second of throughput. And when I say instantly, I'm not exaggerating. I'm talking about literally 0 milliseconds, thanks to automated feedback loops that manage and monitor resources for you. This means no more waiting for hardware to provision, no more idle resources, and no more paying for more than what you need, because Confluent will only charge you for what you use every hour, powered by a new CKU type called elastic CKUs. With eCKUs, when your workload decreases, so do the number of CKUs you pay for, without you having to do rigorous capacity planning and monitoring. We've talked about the Kora architecture that enables all of these improvements before, but if you're interested in learning more, there's a full white paper on it that recently won Best Industry Paper at VLDB 2023. So that's our foundation, the stream. Next, I'd like to touch on Connect, because what good is streaming your data if you can't connect it to other systems? We've got a full suite of integrations to cover any system you may want to connect to. We have over 80 fully managed connectors for the most popular systems, and for everything else, we have a custom connector framework so you and the community can build your own, and we'll run them on your behalf. These connectors can save you up to 6 months of development time already, but we're always making improvements. There are 3 big announcements to our Connect offering I want to highlight today. First, we now offer outbound private networking support across our connectors for both AWS and Azure. Second, we're launching 3 enhanced, fully managed Debezium connectors to make it easy to bring CDC data from Postgres, MySQL, and SQL Server into streaming. And third, we are rolling out changes soon to reduce throughput costs on our connectors by up to 50% to make all of this more affordable. We're also partnering to deliver native integrations to make it easy to create and access streams from Confluent directly within your favorite applications. This means you no longer have to be a Kafka expert to move your real-time data streaming initiatives forward. Say you're a Rockset user. You can see and request Confluent datasets from right within Rockset. And after a simple approval, your data will be up and moving, all with the same security and governance you've come to need and expect from Confluent. Not only do the users in these systems get to move faster, this pattern also unburdens the developers and engineers working with Kafka by making these requests fast and easy to respond to. But it's not just downstream users. I want to show you all how easy it is to use these native integrations to connect to source systems too. For that, we'll run a short demo that connects to a familiar name, SAP, and specifically their DataSphere product. It is my pleasure to welcome Ian Henry to the stage from SAP, who will show you more.
Thank you, Rachel. Yes, SAP launched SAP DataSphere last year, including our partnership with Confluent. SAP DataSphere is what we call a business data fabric, which is really an architectural approach to getting business insight from both your SAP and non-SAP data. Let me show you how that looks. I've got a demo here. We can connect some SAP systems, include some business content. Obviously, SAP data doesn't live alone, so we've got connections to a whole host of other systems. If we scroll down here, we can also see the Confluent connection that we've just launched. Clicking on the Confluent, we'll get all the usual connection parameters, so we can also connect to the Confluent platform, as well as Confluent Cloud. Obviously, when the data is going to Confluent, the schema registry is vitally important to pass on those business semantics from SAP into Confluent as well. So here we can populate that schema registry, and that information will then be passed downstream into Confluent. How we do that? We wrap the data in what we call a replication. That replication has a source and a target. Could be an SAP system. It could be DataSphere itself. And then we pass it on to Confluent. So here we're taking some customer returns data, and we're actually going to move that into Confluent. Clicking on the actual object itself, we can see the usual target parameters for a Confluent system, obviously including that schema registry. We can see the topics that are going to be created. And then we can then check that those target columns, we've got 111 of those from our SAP, what we call CDS view. Move to the monitoring perspective, we can see that is already running. Data's flowing out of SAP, out of DataSphere, and into Confluent. Switching to the Confluent dashboard, we can see the CDS views have created individual topics. We can see the data's coming through in terms of messages being received. We can even get a preview of one of those messages. And of course, the schema has also been populated with those business semantics that we had from SAP. We've populated it now in Confluent as well. And with that, I'll hand over to Mike, who is going to discuss how we can govern that data inside Confluent.
Thanks, Ian. So now that we've got our most valuable data streaming in, let's talk about why governance is so critical to streaming at scale. As Sean mentioned earlier, governance isn't about locking our data down. It's about opening it up. But too often, we're in this tug of war over our data. It feels like on one side, our security and compliance teams who are aiming to protect our data and keep us safe, and on the other side, our developers are trying to build applications quickly to create business value. But I don't think this metaphor is quite correct. I think it's actually a little bit more like that box of cables that we all have sitting in storage. You know the one I'm talking about because your PS2 power supply is in there. Someday we're going to use it again. And we're all pulling at this tangled mess, which represents all the systems that we have to use, each with its own data, its own schema, its own policy, existing at its own level of security and production requirements. It's all designed for a specific purpose. And all the time, new developers are showing up, pulling at these cables, making things worse, trying to use it for unknown purposes. But the problem is, only this tiny sliver of our organization actually understands that mess. And so it needs to be inspected and untangled and viewed end to end before it can be used. And that has to happen every single time. And that's kind of crazy, because we made this data, it's ours. We're already using it. The developers who made it do understand it. They know its structure, and they know its purpose. And we need to do more to harness that knowledge to make our developers and security teams successful. We need to shift our governance thinking left into streaming. Traditionally, we thought about governance as a data at rest issue, but that's kind of a legacy mindset. Streaming is the first point of contact our organizations have with data. It serves both operational and analytical estates, and it's already connected to everything. The best way we can untangle this mess is to make sure it never gets messy in the first place. Streaming is where governance should occur because it's the first place it can occur. After all, the cleanest data is always bottled at the source. So let's talk practically. So how do we do all of this? It starts with schema registry, which provides a scalable contract between our producers and consumers. With schema in place, we can use schema validation and quality rules to validate and enforce data quality. Shifting schema left enables our developers to land data in an untangled state the first time so that it can be immediately used by our entire organization. Once we can rely on our streams, we need to know more about them. And while schema is a great start, Stream Catalog adds technical and business metadata to deliver even more context. Context like who owns it, who created it. Context like it might be PII or secure data. It could be dev, prod, staging data, or maybe it's just a description like customer data. This not only helps with data discovery by developers, but it also lets our security teams know when they should use tools like data masking, or maybe when a new topic should be created that can be more broadly shared across the organization. Finally, we need to know where our data is coming from and where it's going. To do this, we use Stream Lineage as our own personal Google Maps for our data. It helps not just with troubleshooting the current state, but it can be used to go back in time and understand how things have changed. So when we pull all of this together, a data stream with validated data, with great metadata, and end-to-end lineage, what do we get? We get the makings of a great data product. And because it serves both the analytical and operational estates, it's a universal data product. And does this really solve the problems for these teams that we're talking about? It really does. For the security teams, requests become less random, data access is standardized, and data is reusable. Sensitive data can be redacted from the start. And for our developers, they can now find trusted data, track it, and change it without breaking downstream systems or without worrying about upstream systems breaking us. If only we had an internal marketplace or a clearinghouse where we could bring all of this together into one place. And that's exactly what we'd like to show you now. Data Portal, which we announced at Current in September, is that easy-to-use interface that brings this together and makes it self-service. So I'm happy to invite Greg and Adi to the stage now to show you just how smooth working with data products can be when it operates on governed data.
Thanks, Mike. I think Adi and I have the coolest job today because we're going to give you a live demo of some of these data governance features. Now, I need you to all do me a favor. This is a live demo, so if you could get out your rabbit's foot or your talisman of choice so that the internet and the cloud gods shine upon us, I'd consider that a personal favor. So we're going to talk about some examples of building data products. So let me give you the scenario that we're going to work in here. Adi and I work for a retail company that sells clothing. And in particular, we are on the data platform team. So let's just sort of jump in and see what we're going to do here. We're going to start as people on the data owners. And specifically, we'll take a look at some of the data that we have available to us as a retailer. So Adi's going to start here in Stream Lineage view. Now, for those of you who haven't seen Stream Lineage before, on the left, you see the fundamental data sources that we have available to us, the fundamental systems. In the middle, you see the data topics we've built, and as you go to the right, those topics are processed and enriched until eventually they go to their source destination. So let's look at what are some of these data products. We have some things like returned merchandise, orders, customers, and you know as Adi hovers over them, you see the lines that connect the various sources through to the destination. So it helps you sort of, as Mike said, be sort of Google Maps for your data. Now, let's look at a particular one. In this case, let's drill into the customer orders. When Adi does that, this panel comes into the right, and that panel gives me more information about that topic. And as Mike said, it has both technical metadata, how many partitions do I have, what's the throughput like, but even more importantly, it has business metadata. Things like the description of what the actual topic is, when it was last modified, who the owner is. I can even go in, since we're the owners of this topic, and look at the Messages tab and see actual real-time messages that are flowing through this particular topic. And again, as owners of the data, we can actually drill in and look at the schema as well.
Yeah, the schema is the start of our data contract. It helps us understand the shape of our data, and it looks like it includes who purchased what, and a confirmation code that shows that the transaction was successful. I can take this one step further by adding data quality rules that allow us to either transform, substitute, or in this case, detect errors. You can see the confirmation codes being matched against this regular expression, and if the match fails, it goes to a dead letter queue called bad orders. And let's go back and just take a look at that. Sure enough, there's a fresh one, and that didn't match the regular expression at all.
Great, so there we've actually been able to now to build a data contract that specifies not just the schema, but the actual contents of the message. Now let's switch roles a little bit. Let's put on our data consumer hat. And now Adi and I are part of an application development team. In this case, the business owners are complaining. The list of top products is changing so frequently that they're not able to build an inventory system to keep up with it. So how do we solve this problem? Now, normally, this is a huge pain in the neck. We all know this. How do I even go about finding the right data? Well, I can go trolling through the databases I have. Maybe it's one part corporate wiki, one part a Google Doc that nobody updates, one part trolling through Slack. What if there were a better way to find the available, trustworthy data sources? Well, that's what Data Portal solves. We're now looking at the Data Portal. And this is actually the way that I can quickly locate trusted data products. At the top, I have the ability to do free-form text search on any of those metadata fields we saw. But remember those tags that we saw earlier? Here I have all the list of tags in my organization. In this case, I want to pick the data product tag, because I want to pick things that I'm guaranteed are of high quality. Now this has narrowed down the set of topics we have, and there's this one called top selling products. That looks like it might be a good choice. Let's drill into that and see if that's the right one.
Yeah, so when we look at this, we see some familiar details like the description of the topic, who the owner is, the schema, and we can even dig into the stream lineage. This is how you know it's live.
Okay, who forgot their rabbit's foot? And there we are.
So if we look, it highlights and says that this data is coming from the products and orders topics from before. So this seems like the right one. Let's go ahead and request access. So I'm not going to write to it. I'm just going to read. And now if we go back over here, oh, I got an email. Hey, this Adi guy wants to access this topic.
I think he's legit. I think you can let him in.
OK, cool. Yeah, me too. And now, if we refresh this page, hopefully it won't log us out again. Oh, I got some new buttons. I can set up a client, I can query the data, or even do some actions with Flink.
Yeah, hold on, Sparky. We're going to talk a lot about Flink a little bit later, and I've learned it pays to not steal your boss's thunder. So why don't we wrap up that demo for here? So what we saw was we started as data owners, and we were able to build high-quality data products. As data consumers, we were able to use the data portal to quickly locate the right data. And the best part of all this, everything we showed you today is available for free. What regions is it available in? All of them. What do you have to do to access it? Nothing. It's all enabled by default. And with that, I want to thank Adi, and we're going to turn it over to Konstantin, who's going to walk us through how Flink can help us transform this data to make it even more valuable. Thanks, everybody.
Thanks.
Yeah, thanks. It's great to be here. Thanks, Craig and Eddie, for the governance demo. I think all of this will really make an impact, because if we've learned one thing in the last minutes, it's that if you have well-governed streams, it can make you and your whole organization move faster and be more efficient. If we think about, or if we talk about streaming and talk about shifting governments into streaming to the left, then we need to think similarly about processing. And it's stream processing that allows us to take the data that is flowing through the organization and process it while in motion, from simple things like filtering and cleaning, to enriching it with other data sets, to aggregations and sessionization. And when you process this data ahead of your sync systems, ahead of your data stores, you can benefit in multiple ways. First, you can reduce redundant processing, often inefficient processing in those downstream systems. Second, with stream processing, you can build high-quality data products that are consistent for all your downstream consumers and that don't break from these upstream schema changes. And last, and most obviously, sometimes you just need the answers faster than batch processing can provide. Now, if you think stream processing is the right paradigm, and I'm sure many of you in the audience do, then the next question is, which tool do I use? And for that, we have a clear answer, and that is Apache Flink. Apache Flink is rapidly emerging as the de facto standard for stream processing in the market, and the Kafka community certainly has taken notice. If we look at the Flink adoption over and compare to the Kafka adoption over a similar period of time, then we see that both of these projects follow very similar trajectories, just shifted by a few years. And that makes sense. As data streaming users mature, they learn more about what stream processing can provide on top and start adopting it. And if we look at Flink, in the wild, we see most of the time it's actually bookended by Apache Kafka. Those Flink jobs read from a couple of Kafka topics, they process the data, and they continuously publish the results to downstream topics. So this combination of streaming and stream processing is so powerful that we see it in use at many of the most technically sophisticated companies in the world, like ING, Apple, or Netflix. So yes, there is momentum, there is adoption, but why Flink in particular? With Flink, you can build real-time data pipelines, event-driven applications, even analytics and artificial intelligence to solve almost any use case imaginable, from recommendations, real-time pricing, fraud detection, dynamic inventory forecasting, and business monitoring, and much more. And for each of these use cases, you can not only address streaming scenarios, but also batch scenarios. Before I move on, I want to double-click on one of the use cases that is increasingly becoming part of all of the others, and that is AI. And the big buzz in AI is specifically about Gen AI. And those out-of-the-box models, general-purpose models, they're great at answering general questions, right? Like, how many more World Cups does Germany have than England? But they are actually very hard, or they struggle if they need data that wasn't available when they were trained. And they also are not good at actually providing any kind of evidence or source to their answers. And that's where Retrieval Augmented Generation, or RAG, comes into play. RAG provides the business-specific context to your foundational models. And the data streaming platform and stream processing can play a crucial role here, as it allows you to connect all this data that is needed, transform it in a way that it is made available for retrieval augmentation. And this curation needs to happen in real time, because your end-user-facing products need this real-time context to give the best answers. Now, the real trick is that Flink can be great at all of this, at this use case, at the other use cases. But if you thought that self-managing Kafka was hard, that operating Kafka was hard, Flink was even harder. But I did say was. 1 year ago, here at Kafka Summit, Jay announced that we would bring fully managed Apache Flink to Confluent Cloud. And we opened up our early access program for Flink SQL. We then went on at Current 2023 and announced the public preview of the service. And since then, anyone has been able to try out the product and build POCs on top of it. And hundreds of our customers did exactly that. At the same time, we continued to integrate the service with the rest of the platform, governance in particular. We've expanded it to 21 regions across all cloud providers. And most importantly, we've hardened it for production use with our 4.9 SLA. And all of that for a truly cloud-native service. So no clusters, elastic auto-scaling, and scale-to-zero pricing. So with hitting all of these milestones, I'm very happy to announce another one today, and that is a big one. It's that Confluent Cloud for Apache Flink is now generally available for anyone to try out, adopt, and fully put into production. It's really been an intense year to get to this point, and we'll, of course, always continue to improve the service. But yeah, the team is really happy to have reached this milestone, because in the end, it means that we, in turn, can be of more use to all of you and your teams. But you don't have to do that alone. Our global ecosystem of service integrator partners is here to help you design, implement, and solve your use cases. And when it comes to connecting to the rest of your architecture, your analytical systems, your operational system, your AI systems, all the connectors that Rach talked about earlier today, make these systems available as sinks and sources to Apache Flink. Now, this GA is obviously great news, but we've talked a lot about universal data products, and how does stream processing fit in there? I think it's right at the heart of it. I've also talked about how stream processing can make you more efficient by shifting the processing to the left. But all of this can seem a little bit abstract and theoretical if you talk about data. So let's take a real-world example. Let's say we have a shoe. And let's say you're shoe shopping and you get this box. What's in the box? Shoe ingredients. Great. You'd be pretty disappointed. You wanted a shoe, you only got the raw ingredients. But still, in the world of data, this is actually like how ELT and many other data integration patterns work. We dump the raw data parts onto every downstream consumer to assemble and reassemble all from scratch. Does that make sense? No. Doesn't make sense for the shoe, doesn't make sense for data. What we really need is division of labor. We need a set of experts, pre-process the data, create intermediate data products, and then have a different set of experts take these intermediate products and build something downstream. And that is essentially what universal data products are all about and enable us to do. The experts closest to the data, closest to your sensor measurements, your customer profiles, your orders, they become responsible for offering out this data to all the downstream consumers in its most valuable, in a contextualized form. And that's where you need stream processing. Stream processing can make all of these steps of pre-processing, the normalization, the schematization, aggregation, enrichment, all of these steps a million times easier, more efficient, and secure. Before we dive into the demo, one last thing. What we've announced today is Flink SQL specifically. And I know at least some of the software engineers here in the audience might be skeptical of programming in SQL. And we will have you covered with the table API in Java and Python coming soon. But I'm also going to say SQL is actually a great language for data transformation specifically, and it has many desirable properties. Most importantly, it makes the core things that we do much simpler, and that's what we want. We want the simple things to be simple. But we also want the hard things to be possible. We want you to be able to bring your arbitrary business logic, to bring your existing libraries and plug them into Flink SQL without changing a single line of code. And that is where user-defined functions come into play. So here you see an example of a SQL statement with a user-defined function called isSmaller, and its Java implementation on the right. Flink SQL comes with very broad support for user-defined functions, from specific functions that allow you to connect to external systems and external APIs very efficiently, to user-defined aggregations, and up to custom window operators and custom joins. It can be extended in almost arbitrary ways. So alongside the Flink SQL GA, I'm very happy to also announce the early access program for user-defined functions for Apache Flink. So if you're interested in that, if you want to extend Flink SQL on Confluent Cloud, then apply today or any of the next days via this QR code, and we will be in touch soon with the next steps. And with that, I'd like to pass it on to my colleague Mayank, who will show all of you, show you all of this in action: data products, Flink SQL, and UDFs. Thank you.
Thank you, Konstantin. Hi, all. It's been a tremendous experience over the past 1 year building and launching Flink SQL, and I couldn't be more thrilled to be here and show all of you some of the features that I think are the coolest, starting with Flink Actions. Now, what if I tell you, you can actually process data in Flink without writing a single line of code? Well, seeing is believing, so let's roll the demo. All right, so we start with the familiar screen of the data portal that you just saw earlier for our online retailer. We click on the clickstream enrich topic. Now, this has user data for all my web users, clickstream data. There's a particular field called IP address here, which is sensitive, and I want to mask for all my downstream systems. So what do? I go to Actions. Now, you can think of Actions as commonly used pre-packaged data processing steps that you can spin up in a matter of clicks. So I click it, get to deduplicate a topic and mask fields. That's what we are starting with. And for this example, I would actually show you mask fields. Super simple to set up. We select the IP address field, we select the regex, we select a compute pool and the service account, and that's it. We are in action. Now, there are two steps that are happening. First, it creates the destination topic where the messages will go, and it's creating a streaming query of Flink that would actually process data and incrementally update the destination topic. Pretty sweet, right? So now what we will do is actually check if this works. So let's go into the SQL workspace, hit a simple select star from destination topic, click Run, and as the results flow in, you can see the IP address is masked for all of these messages. Now, Konstantin earlier mentioned that we want to make the simple things simpler, and honestly, this is where we have landed. Cool. Now, you've seen how you can write stuff without using any SQL, but for this next bit, I do want to show you Flink SQL in all its glory, and also how you can extend it by writing a user-defined function in Java. And also for this example, I want you to think of the last time that you were shopping online and you had a shirt that didn't fit, which ran smaller. Now on the screen, you see I'm compiling a jar with a simple function that was actually is smaller compared sizes. I'm in my SQL workspace. I'm defining this function using create function, using the uploaded jar that I had just compiled. And it's going to register this function in the Flink catalog. Now, it's super simple. I've already done this. To check it out if it's actually working, let's write a query with some sample data and run it. OK, so the is smaller UDF is working. Good, 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 right? Now, before I actually end up using this UDF, I want to create an intermediate data product. Now, this data product will actually hold information for all the items that were repurchased within 1 hour of being returned. Right? And so I would write a create table query here. You can see this create table query would actually create the underlying topic and the schema itself, so you don't have to worry about that. And I'm calling it hourly reorders. So let's hit run. OK, so this is done. The next step would be actually to write data into this topic. So I'll write a streaming query that will incrementally update this table with the latest data. Now, you can see it's comparing the time diff there, and let's hit run. Now, the cool thing is this is actually backed by a Flink job running continuously on the latest Flink runtime, and it will scale automatically up and down based on the latest workload requirements. And that's the beauty of running Flink in Confluent Cloud. OK, finally, we are going to use our UDF, and we're going to find out those mischievous brands that run small. Yeah? So let's roll the demo. Cool. So I've created this data product. In order to get the brand's information, I need to enrich this with the products topic that actually holds the brand's information. So I'm calling this temporal table join. Yeah? And the next thing we're going to do is actually aggregate per brand how many times the returned item was actually smaller than the repurchased item. And that's where the is smaller UDF comes into play. Let's hit run. And as you can see, we are getting the count per brand. This is a constantly updating result set that you can feed into a live dashboard or into a destination topic. OK, so the SQL workspaces are great for debugging, exploration, and some development. And so is the SQL shell, which comes with the Confluent CLI. But I know for most of you, you don't want to do production deployments using this, yeah? And that's why now you can use the official Confluent Terraform provider to securely deploy and manage your continuous running Flink applications. With that, I would now like to invite Jay onto the stage. Thank you all.
Hello, everyone. Couldn't be more excited to be here, and I couldn't be more excited about some of the functionality we just talked about. That Flink service is something we've been working on now for over 1.5 years. We brought together a team of people who'd worked on making cloud data warehousing elastic at Google, had worked on some of the largest data systems out in the world, along with some of the people who helped create Apache Flink and worked on the internals of that system. And I think that was a pretty magical combination. What we wanted to do was offer stream processing functionality that took all the burden out of running it and made it something that was as easy and approachable as any batch system was. But the things that we just announced, it wasn't just about Flink and the processing layer. We actually announced new functionality for each of these major capabilities. In the stream, we've made Kora 16x faster than Apache Kafka. We announced our single CKU enterprise clusters. In Connect, we added private networking. We added new Debezium connectors for Postgres, MySQL, SQL Server. In governance, we added our data portal and Flink integration. And so all of those are really a big deal. But when we think about how do we make streaming easy, how do we make this the mainstream way that people work with data, it's not just about the features and functionality. It also matters that we make that efficient and cost-effective. And so over the course of this presentation, you heard a whole set of improvements on that dimension as well. Over a 50% TCO reduction with these enterprise clusters for Kora, 50% price reduction on the throughput for connectors. Our entry-level governance offering is now freely available in all regions for all customers. And maybe most importantly, the model for our Flink offering is incredibly cost-effective. It scales to 0. It scales up automatically to just what you need. It does that in sync with your data set and takes care of the operations and evolutions and upgrades all behind the scenes, making it much easier to run stream processing jobs in production. So I'm really proud of all the work that the team at Confluent has done. But there is one other big thing that I want to talk about today. And that's about unifying the world of operations and analytics. And to touch on that, I want to go back to what Sean started out by talking about. He said, in every company, there's an operational estate, all the applications that run the business. And there's an analytical state, the place where we do our data analysis, the data crunching behind the scenes, the data warehouse. And I want to talk about how these areas are built and how they come together. So let's start with the operational state. We talked about this. This is that big data mess. All the SaaS apps and microservices and databases and all the hand wiring that knits it together. But like we said, there is an emerging de facto standard, Kafka, which is an open way of integrating all these things, bringing them together around data streams. Data streams is the abstraction that unifies the operational estate, and Kafka is the open standard for data streaming. But what about the analytical state? If we go over to the other side of the house, what's happening over there? Well, it's a similar mess. There's a bunch of technologies. There's every type of data warehouse and lakehouse and new AI product and reporting layers and vertical SaaS systems. How do they come together? Well, you can definitely feed these off streams of data in Kafka, but the actual way that systems here integrate isn't as much around streams. It's around shared tables. Ultimately, that's what you have in a data warehouse, is a bunch of tables you've populated with data that many different reports or jobs access. But today, in most companies, these tables are fragmented across a bunch of different technologies. You have some tables over here in your data warehouse, some things over here in your lakehouse. But there is a better way of doing this. The increasing trend is to put these tables in some kind of shared object storage in S3 and make them available across systems so that the whole analytical state can access the same data sets. And increasingly, there's an open standard for this as well, and that's Apache Iceberg. This is an open source project and a technology that exists to unify the analytics world, to make it so that you can have shared tables of data stored in S3 or other object storage. These can be built in a highly efficient columnar format that maintains the typing and structure of the data and makes that available to the full ecosystem of analytics tools. Everything from Snowflake to DuckDB can all access the same shared tables of data. So in each of these worlds now, there's some way of sharing data across the systems that need it. But how do you actually connect them together? How do we connect the operations world and the analytical world? Well, this happens all the time today. The easiest way to do this is pump those streams of data from Kafka out into the data lake to fill up these Iceberg tables. And of course, this works. But there are some drawbacks. This is ultimately just kind of a surface integration. For each of these streams of data, we have to kind of manually map it into some table. There's often some kind of hand-maintained Spark job for each one of these that tries to extract the right schema and match up column by column and field by field where it goes. And keeping all of that running is a lot of work. Somebody changes something upstream, and everything downstream breaks. Or worse, it silently breaks, and you don't know till some days later when all the data everywhere is polluted now with the wrong results. And so that's not really the final form we want. Surely there's something better we could do. What if we truly united these things? What if we really brought them together? What if we actually made this more like one system that was unified? Instead of just duct taping the two things together, what if we had like a real integration between streams of data in Kafka and these shared tables of data in Iceberg? What if we could converge the streaming and batch world? This is actually not a small project if you do it right. It's actually a big project, and it has to cut through at least 3 critical layers of the stack: the stream, the governance and schemas that cover this data, and the processing that sits on top of it. And that's exactly what we've done at Confluent. Now in Confluent Cloud, we've really brought these two things together. We've made it so that we have the exact same data that's stored in Kora is available now as Iceberg tables. The exact same schemas that are in our schema registry are projected out onto those tables, and our processing engine, Flink, covers both of these. So let me dive in and talk about how we do this layer by layer. If we start with the stream itself, that shared data, the way we do this, what ultimately makes this possible, is the underlying architecture of Kora. We talked about how Kora has a cloud-native architecture where the storage of the data that's in the topics is actually already in S3. It's already in object storage. It's in the cloud object storage. And that means each of your topics is already represented there in a set of files. And that is actually what the underlying stream or commit log is in Kora. So unifying that with Iceberg is not an impossible thing to do. We just have to have the ability to translate between these representations, the ability to actually map these streams into tables in Iceberg. And this is a concept that's actually well understood in the stream processing world, this idea of a kind of stream table duality, that you can extract a stream of data from some stored tables, maybe a change data capture stream, that you can transport that around, transform it, and rematerialize it as a table somewhere else. This is a common thing that people know about. But what we've done now is actually kind of reified that, made it real in the engine of Kora, so that now the stored streams of data can be also materialized and represented as Iceberg tables. And we can do this end to end. And we call this new functionality table flow, because you're taking this streaming flow of data and turning it into tables as it arrives. And this is a fundamental part of Kora, and we are announcing early access to this today. This is going to be delivered in a couple of phases. In phase 1, we're taking the data from Kora, we're making it available in Iceberg. In phase 2, this will work bidirectionally. The data in Iceberg will also be used for Kafka consumers to read from. And then finally, in phase 3, the rest of the data in Iceberg, even things that didn't flow through Kora, that didn't come from streams, can be opened up as well. So you can make your whole data lake subscribable and power things like reverse ETL, or make those so simple you don't even need a name for it. I think this is an incredibly powerful feature. I think this actually does an enormous amount to unite these two areas, and is the best way of getting structured data into a lakehouse or warehouse out of the operational world. And that last bit there is actually really important, this idea of structured data. Because it's not enough to just get the bytes from one place to the other, to take them from system A and kind of dump them in some form in the lake. That's not actually going to be usable. A lot of where the problem is today is in the mappings of the structure of data, what it actually means, what the columns are, how they map into the tables that you have, and how those break. All those zillion Spark jobs and all those silent failures, they come out of that. And that leads to the governance area of what we've done. We've made it so that you take the schemas that you would represent for streams, that you would store in our schema registry, and you can map these schemas directly into the Iceberg tables in the lake. And this propagation is automatic. It's not something that you have to do column by column. It's something that's done automatically, and it respects one of the more powerful aspects of our schema registry, which is this idea of forwards and backwards compatibility, that you can have rules around how you're able to change these schemas, what future applications are able to do. And this is a really powerful thing. It means you can take this schema for your events, translate it into an Iceberg table automatically, be able to still evolve your event schema, but respect that in the mapping into the table, be able to prevent changes that would break compatibility, and be able to do that upstream, be able to shift that responsibility left to the upstream application. So instead of just silently getting bad data in the data lake, or instead of having all your ETL pipelines die, instead, now the person developing the app gets an error in development saying, no, that's not a valid schema change to make. You can't actually evolve it in that way. That's not going to be compatible with the 2 years of data that you stored historically. You need to find a different path. And that's an incredibly powerful thing. That actually allows us to do something really big. It allows us to actually unite these two worlds in a really natural, native way. The operational state and the analytical estate can all be united around these universal data products that are available across the entire company, that are available in the native form on both sides of the house, to the operational applications as real-time streams that populate the data systems in that world that trigger actions in the microservices and applications there, and as shared tables out in the lake or warehouse. So this is a really big deal. But to really take advantage of it, you need the last piece of the puzzle, which is the stream processing. And to do that, you have to really unify stream and batch processing. After all, batch processing is the domain of the lakehouse. It's the domain of the data warehouse. That's where these big batch processing jobs run. And the technology that makes this possible, of course, is Flink. Flink has done an amazing job of really creating an abstraction that unifies streaming and batch. And in what we've done in Confluent Cloud, I think we've taken this to the next level. Flink lets you have unified semantics. So you can build an application or query which runs against data at a point in time, as it is right now. But you can take that same application and query and go run it against the future data as it changes and updates. You can take something that was developed in batch and run it as a streaming thing in production. The same program can be used for both. But what we're enabling with Tableflow is actually even more powerful, because it unifies the data that is in Kafka, those last few seconds of real-time data, with all the historical data that is stored out in Iceberg. And it does all of this transparently. You can think of this as all just one big stream, end to end. And the engine takes care of all the complexity of mapping between these. And this means that you can fall back on these large data sets for reprocessing of data if your logic changes. It means you get all the efficiency and performance of these columnar formats, which allow really efficient compression and the ability to do high throughput processing. It means that you get the last up to the millisecond results from Kafka. And most importantly, it means you can eliminate all the complexity of trying to jury-rig these things together yourself. Some kind of Lambda architecture thing where you have to build it once off in batch land to populate the historical stuff, and once in the real-time world, and somehow glue those things together. Instead, you get something that really is an end-to-end Kappa architecture that processes from the past into the future with the ability to store as much of the past as you like. And of course, the goal of this, the real power of it, isn't just Flink. It's not like you just want one engine for all of this. The point of Iceberg is actually to open this up to the full ecosystem of technologies in the analytics world, almost all of which these days work with Iceberg, almost all of which are now open to these shared tables of data, whether that's Athena or Dremio or Starburst or Snowflake. All of these systems can now be powered by these shared tables. And I think this is an incredibly powerful thing, an incredibly important destination for data. And this functionality really adds value on both sides of the house. It makes the lakehouse better because now your data arrives in real time. There's no more waiting for the daily dump of data to arrive out of the operational realm or for the hourly diff to turn over and get processed. Everything shows up as a stream as quickly as possible in minutes. The transformations that you want to make that data usable can be done continuously in real time in Flink on top of that data to have it land in a usable state. And most importantly, the painful error-prone mappings go away. But this isn't just about an easy way of getting data into your lakehouse. It also makes the data streaming platform better. You now have infinite retention of data out in S3. And most importantly, since you were going to retain that data anyway in your lakehouse, and because it's shared between the two, it's essentially free. You get to store it once between both systems. You get the ability to reprocess that data that you've stored whenever you like. And the compaction of compacted topics becomes much more efficient and automatic. So that's enough of me talking about this. I think it's time that we see TableFlow in action. And for that, I want to welcome to the stage Danica Fine, who's going to demo this for us. Danica?
Thanks, Jay. Whew, good to be on the stage. Technologies like Kafka, Flink, and Iceberg are essential in building out valuable data products for use across the analytical domain. But how are developers, how are you, handling this process today? Suppose you wanted to build a pipeline to refine and share your data products across the vibrant ecosystem of S3 tools. If you've done this before, and it's very likely that you have, you know how much work it is. And if you haven't yet had to do this, or if you've somehow forgotten how bad it is, let me refresh your memory. Your data's in Kafka. So you need to spin up and maintain infrastructure to consume that data out of Kafka, transform it into Parquet, and store it in your data lake. Now, it's 2024, folks. This is a solved problem. We have a lot of technologies to help us do this. You could spin up a Kafka connector, or maybe you write a Flink or a Spark job to make this happen. But while you're doing it, regardless of whatever technology you choose, you need to make sure that the data that ends up in your lake isn't garbage. Yeah? Do any schema validation. You should maybe check your type conversions. And at that point, you might take a look at the files that are ending up in your data lake and ask yourself if they're actually useful. Are they properly compact? The answer is probably not, so you write a compaction task. All right, all good. Until you get that dreaded call in the middle of the night that says that somebody upstream changed a schema and the entire pipeline is broken. Nice. So you spend a couple hours, maybe the next day, repairing it all. And maybe that works as sort of a one-off thing, but we don't just do that once. You have to do this again and again, dozens of times, hundreds of times, for every Kafka topic, every data set you want to end up in your data lake. And that's not sustainable. It's tedious, it's hard work, and we're maintaining fragile connections between these two systems. And I know we can do better. So this is exactly the problem that TableFlow is here to fix. It consolidates, it automates all of those tedious little tasks, and helps to make your data performant in your data lake faster than ever. So I wanted to show that off today, and full disclosure, Jay wanted to be out here for this demo, but I wasn't quite sure he could pull it off. So let's see what we can do. So on Confluent Cloud, say I want to take this returned merge topic, and we want to make this available in our data lake. All we have to do is click the Enable TableFlow button. All right. That's it. That's the demo. You can clap, yeah. And you know, on second thought, maybe Jake could have done that, so I'll remember that for next time. But actually, I know that was simple, right? We clicked a button, it did what we needed it to do, perfect. But I do want to give credit where credit is due. So let's take a look at what's happening behind the scenes. It all comes down to the Kora storage engine, where TableFlow fits neatly between our compute and object storage layer. So when we click that Enable TableFlow button, Kora starts getting to work, handling all of those details. It starts handling those tedious tasks that we discussed in that first workflow. And the end result is that we have this beautifully clean and compact Parquet files that are stored alongside Iceberg metadata files in Confluent Cloud Object Storage. And at that point, it's kind of like a Schrodinger's cat situation. Jay said it's being stored once. And so when you're looking at that data from S3, it's Parquet. When you're consuming it from the Kafka side of things, it's your Kafka data. And it is on Confluent Cloud Object Storage. And so future versions of Tableflow will allow you to bring your own storage bucket. But the data is there, so whenever you want to access it, you're free to do so from whatever compute engine you like best. And so on that note, let's try a couple compute engines out and see how our data ended up from our enable Tableflow action. So back on Confluent Cloud, to make use of our Tableflow data, we first copy the Apache Iceberg Redst catalog endpoint, and we can go use that in whatever Iceberg-compatible compute engine we want. So here I'm in AWS Athena in a notebook, and so I take that endpoint that we just copied and make sure that's input here. And of course, we also want to make sure that the proper credentials are in here as well. And so we save. And now we can run a show table command just for proof that that data's there. Give it a second. All right. As expected, we do see that returned merch topic. And now no demo would be complete without a select star. So let's run that now just to be sure that the data is there. And we see it. In addition to the REST endpoint, we will support other ways for you to connect to your data. So let's head over to Snowflake and see how this works. There are additional steps here, but it's just as simple. We create an external volume, do a catalog integration, and create our table. But then, of course, again, we can run our select star on this data. Right. And there we go. There's our data. It truly is a headless and open architecture where you are empowered to use your own processing engine. So Tableflow brings the operational and the analytical states together with the push of a button. And I'm excited for this, and I hope that you are just as excited for how easy this workflow can be moving forward. And with that, I'll hand it back to Jay. Thank you.
Awesome. Well, I wanted to take a few minutes and reflect a little bit on what this means. If you step back, what does all this come together actually mean for us? We saw a little bit of Flink, we saw a little bit of governance, we saw a little bit of Tableflow. And it made me think a little bit about what's happening in data streaming in the large. And I think if we went back 5 years, and we asked maybe the average technologist about streaming if they knew about it. And we said, how does this fit into your architecture? How does it fit into your world? And they probably would have said, well, it's very cool. We're going to have some streaming stuff. It's going to be very quick. But it's kind of a niche. It sits a little bit on the side. The default is ultimately batch. That's the way most of the world works. That's the way things are. And that's what they would have said. And I think that would have been the answer most people gave. But if you think about that answer, it's a little bit odd. After all, business is a continuous thing. Reality is happening in real time. Increasingly, the needs of applications need to make decisions and feed that back into the operation of the business. And if you're doing that only once a day at the end of the day, it's very hard to do. And so, the way these data systems work, if they're batch-oriented, is a little bit at odds with the way the world works. And so you would think, well, why is this? Why is it that this is the way things are? And if you asked that same technologist 5 years ago, they'd probably say, well, that's true, but ultimately this streaming stuff has a set of inherent limitations. There's a set of things it just can't really do. Ultimately, you're not going to be able to get something that's transactionally correct. Or it's just not going to be as efficient. It's going to be a lot more costly to run something that's real time. Or it's just too hard to do it. It's just too hard to use. And at the time that they said that, all of that might actually be right. It might all be true, at least of the systems we had at that time. But I think what's happened over the last 5 years is this area has really evolved. It's now the case that you have strong guarantees for stream processing systems, real transactional correctness at the Kafka layer, at the Flink layer, for the combined system working together. It's now the case that some of the largest scale, most efficiency-oriented systems in the world are streaming systems. And that's often the most efficient way to do things. And increasingly, putting these things together, bringing the full set of capabilities in a cloud offering makes it very easy to use. In fact, much easier than trying to build out a bunch of micro-batch pipelines that run every hour and string them together. And so I think a lot of what we thought of as inherent limitations were just the limitations of that moment. None of them were deep. And virtually of all of them have gone away. And so when we look at what's possible now, when we think about what's possible in a modern data streaming platform, something really interesting becomes clear. It's not that streaming is some niche that sits on the side. Actually, it's giving the ability to develop applications or queries that process data at a point in time, but can also keep running on that data as it evolves. It's actually a generalization of batch processing. It's something that is a superset of that. And I think that functionality is actually critical to the next wave of applications that we have to build. Konstantin talked on this a little bit in his presentation when he talked about what's happening with architectures for AI applications. These are applications that are built against data in a very different way. You need to do the development against the data to see how it actually comes together. And that's ultimately a kind of analytical processing, how you're munging that data and getting it into the right form. But then they go and deploy out in the operational estate and run in real time with high SLAs. So ultimately, that's an application that kind of spans both the analytical world and the operational world and pulls requirements from both. And it actually requires that very generalization of batch processing. Can I build something against some static version of my data set? And real-time processing, can I take that and run that in sync with the business and give answers that are up to date with how the business is working? That's exactly what you need in the world of AI. And it's not just AI, it's a whole modern class of data-intensive applications, whether that's improving the customer experience or driving more efficient logistics end-to-end throughout the business. There's a set of applications that work this way and require that functionality. And that is what is being enabled by this new data platform, the data streaming platform. And I think the three key interfaces for this platform that Confluent's betting around are these. It's Kafka for that core stream that unites the organization. It's Flink for the real-time processing on top of that. And it's Iceberg to be able to share these tables of data more broadly. And I'm incredibly excited about what this makes possible. I'm incredibly excited about that ability and vision to really unite all the parts of a modern company. And I think it's an amazing thing to be able to work with all of you and see the innovation that's happening around this area as this area of data streaming is built out. And in fact, as the last part of this presentation, I want to share a few great examples of that very innovation. Last year at Current, we announced $1 million in prizes for our Data Streaming Startup Challenge. And I'm going to invite to the stage now our CMO, Stephanie Buscemi, who's going to tell us a little bit about the finalists and the winners for this challenge. So Stephanie, you want to take over?
Thank you. All righty, as Jay said, we have some exciting use cases to share with you here, but just a quick word on this data streaming challenge. We announced this 6 months ago, and the reason that we did this was we want to grow this data streaming ecosystem. It is growing, and we want to continue to grow it and grow the community. And Confluent wants to do that by investing in these companies. So what we did was we said 6 months ago, out to the startup community, if you have been in business less than 5 years and you have less than 10 million in total VC funding, you should try our data streaming challenge. And that is what we have done here. So we've taken these and we've received hundreds of submissions from around the globe over the last 6 months, and we've paired them with a wonderful lineup of judges. Now we have some of our judges right here on stage with us, but in addition to having Jay and Sean from Confluent, we reached out to the VC, the venture capital community, and we got some of the very best to participate in this. We had Eric Vishria from Benchmark. We had Matt Miller from Sequoia. And I'm very thankful to say we have here with us today, sitting here in the middle, Carlos Gonzalez Cadenas is joining us from Index Ventures. So let's give it up real quick for our judges that we have here. Now, as I said, hundreds of submissions across 22 countries, across all different industries out there. We took this down to 12 semifinalists, of which you can see here on the screen, all of these. And all of these semifinalists were awarded 5K and Confluent credits to get them going on their data streaming initiative. But the reality is, there can be only one winner. So we've taken it down to 3 finalists. And these 3 finalists have spent ample time with the judges. They've spent extensive time with these judges, going through their businesses, the opportunity, looking at what they have built here together. And what we're going to do right now is we're going to give them one more opportunity to present not only in front of the judges, but in front of all of you. So we have joining with us our 3 finalists here, Atomic Tessellator, Bussy, and Twin Labs AI. Let's give them a round of applause. With that, I would like to invite our first of the finalists up. We have Alon joining us here from Atomic Tessellator, pardon me, a AI chemistry platform. Come on up and tell us your story.
Thank you. Hello, everyone. I'm Elaine from Atomic Tessellator. We're a computational chemistry company that's focused on small molecule catalysis. So a quick sort of 10-second intro into what a catalyst is. A catalyst is a substance that you put into a chemical reaction that speeds it up, but doesn't get consumed or modified in the process. So they're quite challenging to find. They're really challenging to find because on a molecular level, there's many factors that go into finding a good catalyst: the composition, the structure, the surface properties, the reaction conditions, many things like that all have to be simulated accurately and then approximated and then simulated, actually built into the lab. So catalysts are everywhere in our society. So like all of the fertilizer that produces all of the food that humanity eats, the jet fuel that flew you here today, the margarine in the sandwiches you eat, the polyester in your clothes, plastics, rubber, everywhere. 40% of global GDP has a catalyst somewhere in the production chain of it. Now, they're really difficult to find because it's really hard to compute them, and also the tooling that's there is very, very poor. It's very fragmented, it's incompatible with each other, and even worse, sometimes the tools fit together, they look like they're working, but they're producing garbage results, and you don't really know why. So those like frustrations, really hard to compute, and very poor tooling is why I built Atomic Tessellator. So there's a architecture diagram on the right there. It's like a streaming first platform. There's kind of 3 key things that matter. So one is we have an AI that speeds up DFT simulations without going into really complicated chemistry. DFT is like the approximation of force fields that we use. This means that we don't have to have a supercomputer. We can run these, approximate it with an AI model, and then do the fine-tuning with quantum confirmations later. Next up, we have machine-discovered features. So they give us the ability to decide what's important in a molecule, and we have 4,500 machine-discovered features that put us at #1 on a bunch of global molecular leaderboards. And then the final part is the actual streaming system. So what you have to do is you have to build a streaming system so that you're not doing batch simulations on a supercomputer. Every time you do a simulation, the result is fed back into the system, and then that decides what further simulations should be done. This offers us a speed up that's so great, it's not a question of convenience, it's actually a question of viability. So you wouldn't be able to do this kind of experiments if you didn't have a streaming architecture. Molecular space is huge, just to wrap up and give you a reason why streaming is really important here. If you were to take all of the millions of molecules that humanity has produced and represent that by 1 grain of sand, then all of the unexplored molecules in surface chemistry would be all of the other grains of sand on every beach on Earth times 1 billion Earths. Right, so molecular space is that large that we haven't explored yet. We have to be able to continually refine our ideas through a streaming infrastructure because that's the only viable way to do it. And that's why I think that the streaming infrastructure is not only the future for computational chemistry, but computational science in general. And that's it for me.
All righty, stay right here with me on stage. Don't leave. Alan, don't leave yet. Yeah, we got our judges here. They've got a little feedback for you. But I will say, you talked to me about molecules and motion, and I just want to say if this all doesn't work out, you have a job in marketing. So just want to let you know. But with that, I am going to ask Carlos to kick off here and give us a little feedback to Alan on what you think.
Thank you very much. Well, first of all, Alan, congrats on the phenomenal business that you're building. This is an incredibly exciting application of data streaming and Confluent's technology. I think the thing that I am super excited about is that I think the deep learning has an incredible potential in terms of the discovery of new materials and new chemicals. And obviously, the value that can be unlocked by that is absolutely tremendous. So this is a very exciting area to build. I think my only feedback and question to you is on the commercialization side of things. In terms of what path is best to commercialize. Is it better to basically go more on a software path whereby you basically will sell your software to millions of users and developers that are interested in using it? Or on the other side, whether it's better to go to the path of IP and licensing, whereby you will keep, the software, for you. You will use it to discover different chemicals and materials, and then you will basically patent those materials and commercialize, them. That's the open question in my mind. But overall, super exciting business. Yep. Congrats.
I can answer that if you like, or maybe later.
We're going to come back to it, but the point being is the exchange here, the time that has spent with you guys together, and just the audience getting to hear a little bit of the feedback from the judges directly. But once again, give a round of applause to Alan. Thank you. Okay, keeping it moving forward, we are going to have our next finalist up here, and we're going to have joining us is Lewis and Brady from the Bussy team. So come on up.
Thank you. Booking group ground transportation is a disconnected, tedious, and manual process, with less than 1% of the $60 billion in global bookings happening offline. Bussy is building the operating system and e-commerce layer for group ground transportation companies. We are giving them all the tools to digitize their end-to-end process, launch e-commerce directly on their website, and really for the first time in the industry, digitize their inventory and pricing and bring it online to make their services accessible to consumers. Our unified solution is making booking group ground transportation as simple as buying a flight or booking a hotel room.
So data streaming is really a true central nervous system to our platform. It's provided real-time access to data in an historically data-scarce industry due to the fact that data has been locked away in filing cabinets for decades. Data streaming has helped us break down data silos and has enabled asynchronous processing where applicable. And it's been powering every new capability of our platform over the past year. We've seen a ton of improvements in speed and agility with which we can deliver business value to our clients. A recent example of where data streaming came to the rescue was the creation of the Charter Experience Finder, codenamed Chef. To build Chef, we leveraged fully managed connectors, self-managed connectors, and KSQL DB to unlock, enrich, and aggregate data from 13 siloed databases across our architecture. We then built a powerful search engine on top of this data set, which powers our core application and reduced latency in that application by nearly 300%. We're extremely excited for what the future holds for Bussy, and we're so happy that we can build on such an incredible technology. So thanks.
Thank you.
Stay right here. Thank you. Fantastic, fantastic, fantastic. As a head of marketing, I do a lot of events, and I appreciate what you're doing on kind of transforming the way we go about group ground transportation. So I think it's fantastic, but more importantly, you got to hear from the judges here. So I'm going to turn to Jay and ask Jay to give some feedback.
I think it's awesome. I thought one of the coolest things about this is how it has the ability to improve kind of all the parts of your customer's business, right? The internal operations the service runs by, but also how they acquire customers, how they actually find people who come to them, but also the customers' experience themselves if they can figure out where is the bus. And so I think it's rare that you see something that's so end-to-end like that. So I think it's actually a very powerful position to be in. I think the one challenge to try and navigate is how you can actually take that to market efficiently across all these small providers. What's the right combination of product-led growth and sales to be able to actually land that and get it installed and plugged into their systems to provide that capability effectively. I think if you guys solve that problem, then you're off to the races.
Fantastic.
Thank you.
All right, round of applause for the Bussy team. All right, last but certainly not least, we have our team here, both Peter and Rob, joining us from Twin Labs AI. Come on up, share your story.
Well, thank you. I'm Peter. I'm the CEO of Twin Labs AI.
Hi, and I'm Rob. I'm the Chief Product Officer.
So Twin Labs AI is the next generation digital twin platform for live events and venues. Now, if you've been to live events like this, you've probably seen plenty of these around. Most events today are run on spreadsheets and radios. But if you want to really manage your safety and security, you want to run an efficient event, you want to create a great guest experience, then you need real-time information.
And that's why we created Twin Labs. Our platform allows you to create a virtual 3D model, a digital twin that mirrors physical objects, systems, or venues, such as this conference center, all with real-time information. Simply seeing that live data on a 3D map radically improves your understanding of the event. You can suddenly see things like those staff are closest to that incident. Our platform allows our customers to more easily build and operate a digital twin 100 times cheaper than current solutions. How do we do that? Well, digitizing the real world is complex and messy. So how do we simplify that? We simplify it through pre-built integrations and templates. Under the hood, we have a loosely coupled microservices architecture. Our customers have a wide variety of data sources, and that's where Confluent Cloud comes in. It gives us the ability to do things like schema validation and the scalability to deal with all of that messy real-world data. And lastly, under the hood, we've got an AI platform that helps us manage and orchestrate the services, really acting as architect and data analyst for our users.
So live events and venues are really just the beginning. Other industries like transportation, utilities, and retail have a lot of the same challenges. So we're just getting started. So we're Twin Labs AI, digital twins made easy. Thank you.
Nicely done, nicely done. Endless applications and possibilities for you. So very excited with that. And we're going to turn over here to Sean to give a little bit of feedback.
Awesome. Yeah, I really love the solution you guys have built. I think it's interesting how messy but important the real world is. These large-scale events produce an enormous amount of data, all of which is just you're not able to capture or really put to work, and instead you're on radios or spreadsheets. So it's incredible that you guys have thought not just about how the data is delivered, but also how it's presented with the 3D maps, visualization, so that people can take advantage of the data and truly understand it. I think the question would be, just as the users of these types of products are really fragmented, the events are fragmented, the ownership of the forums are fragmented, it's going to be how do you push this kind of idea in an extremely fragmented user base and an extremely fragmented industry. But it's going to be interesting to see what you can do.
Thank you.
Very exciting. Round of applause for the Twin Labs team. All righty, so as we wrap up here, you've heard from all three. You've gotten a brief overview of each, and in just a moment, we're going to announce our winner. But we want to remind everyone that we do have the Confluent for Startups program. If you're interested, take your phone out, take a picture. We're giving hundreds of credits out to different startups out there to help you get started with your data streaming initiatives out there. Please join the community, and you'll get a lot out of it. And with that, I think we're ready to name who is our winner. Now, to name our winner, I thought it would be better than me to have an entrepreneur, a founder of a startup themselves do that. So I'm going to ask Jay to come on up and name the winner.
All right. Without further ado, the winner of the Data Streaming Startup Challenge is TwinLab AI. Congratulations, guys. Really nicely done. And another round of applause for everybody who participated. I think these were all amazing companies. Congrats all. Thank you. All right, we're almost there. One last thing, I do want to ask everybody to save the date. So we're incredibly excited about the event today, but we do have another one coming up a little more than a year from now. One of the things that we've done in the US is actually broaden the tent a little bit. So Kafka Summit there, we actually took from just being Kafka to being a broader event that included stream processing, analytics, AI, the governance of streaming data, kind of the full ecosystem around. And that event is called Current. And we're going to be doing the same thing here. So save the date next year. This event is going to be bigger and better, and we're incredibly excited to do it. And for those of you who love Kafka and all the Kafka content, don't worry. There's going to be a Kafka Summit track that's at least as big as everything we have in this time today. So that's it. This is coming up. And with that, I want to invite you all to enjoy the rest of the day. There's amazing sessions. There's amazing conversations to be had. I couldn't be more excited to meet with many of you. Thank you all for joining us.